Hello, thank you for joining this session. I hope you are doing good and staying safe. My name is Brice Pellet, and I'm a Principal Mobile Solution Architect at AWS. In this session, I'm going to talk about best practices to securely operate GraphQL at scale with AWS AppSync. Now, what I'm going to do in this session is talk about the capabilities and the functionalities that AWS AppSync brings to the table that allows you to take your GraphQL APIs at scale in production. I'm going to give you a quick overview of what AWS AppSync is, and then I'm going to dive into how you can actually set up AppSync and use some of the functionality that it has to protect the access, the availability, and the performance of your APIs. And then we'll look at the tools and mechanisms that you can actually use to deploy these capabilities reliably and with confidence. So let's dive in. So AWS AppSync is a fully managed GraphQL service that runs on AWS. It helps you build scalable applications and connect your data sources that are in your AWS account. It is also a foundational block that allows you to build real-time applications and applications that require offline data access. There are many benefits to AWS AppSync. First of all, as I mentioned, it's a managed serverless GraphQL service, so there's no infrastructure to manage. All you have to do is bring a valid compliant schema and you can get started right away. AWS AppSync helps you connect data sources in your account. So it works out of the box with data sources like DynamoDB, AWS Lambda, with Elasticsearch. And so you can connect those easily and to create full-blown applications. One of the great things about AWS AppSync is that it allows you to connect to any AWS service on your API. So you can use it to connect to any AWS service that you want by using the HTTP resolvers. It also allows you to do things like implement conflict resolution and conflict detection into cloud. AWS AppSync also provides a large set of enterprise security features, things that allows you to do to set up things like multi-authorization, set up access control, integrate with AWS WAF, and it also provides the monitoring that you need to actually track the performance of your API. And we're really going to dive into some of those features and how they can help you. Now, when you talk about deploying an API, the first thing, of course, you want to do is deploy to API, and you use a schema, you connect your data sources to do that. But there are other things that you do need to think about. So first of all, you need to think about protecting access to your API. And so what I mean here is making sure that only authorized users have access to your API. But you also want to make sure that you can support multiple access patterns to cater to different type of users and different type of systems that may have access to your API. And you want to give them the specific access that they need. So you want to be able to be granular with the access that you provide. You want to protect the availability. And here we talk about making sure that your service is available and that it provides the level of service that your customers expect. You want to provide them with the experience that they have come to expect. This means things like making sure that you're maintaining the uptime of your service, limiting the availability to trusted sources as well, and making sure that bad actors do not impact your service. So you want to be able to block the bad actors. You also want to be able to protect the performance. And protecting performance starts by making sure that you can actually monitor what is going on with your API. So monitoring constantly is really important. You want to be able, if need be, to also analyze in real time. So tracing the calls to your API, tracing the different components that are involved in resolving a field in your schema is also very important. And when you've got those two things set up and figured out, you want to be able to improve over time. You want to be able to fine-tune your resolvers and your API to provide that performance. Last but not least, when you've got those things figured out and you've got those best practices and implementation set up, you want to be able to redeploy these over and over with confidence and make sure that every time that you deploy an API, you've got the capabilities that you need to go into production. So let's dive into these, and let's start by talking about protecting access to your API. Now, AppSync allows you to deploy secure and protected endpoints. One of the things that you need to keep in mind when you talk about AppSync is AppSync always requires some type of authorization to get access to the API. So AppSync allows you to create GraphQL endpoints, and there's always some type of authorization that you need to provide to get access to the API. So there is no anonymous public access allowed. There's always some type of credentials that you need to provide to gain access to the API. And AppSync provides a couple of authorization modes. So depending on what you want to do, depending on who is accessing your API, you may want to choose a different authorization mode for that use case. AppSync supports API keys. It supports OpenID Connect and JWT tokens. It supports Amazon Cognito user pools, which also uses JWTs. And then it also supports granting authorization based on permissions set up via IAM. So you have the flexibility to choose the right authorization mode to fit the access use case. And it's important to kind of understand which authorization mode makes sense in different situations. So let's look at that. The first mode that we'll look at is the API key. Now, this is a mode that allows you to simply specify a header in your AppSync request. The header is called XAPI key, and provide the value of an API key that you've set up on your API, on your AppSync API. So you can go, for example, into AppSync console, go into settings, and set up an API key. So this is a fairly simple but efficient mode to use when you're getting started. Maybe you're just getting started with AppSync and you're building out a demo. This is a great mode to use. It's also a great mode to use where you are providing what are essentially public APIs, when you have no specific authorization requirements to implement and there's no type of granular access control that you need to implement. It's also a great mode to use for business to business or machine to machine use cases. So let's say that you have third-party partners that are accessing your APIs and you want to provide them different levels of access. You can specify different API keys. So this makes sense there. Or maybe you have remote servers that are accessing your APIs and you can securely deliver to API keys to those servers. API key makes sense in those situations. Let's take a look at Cognito user pools. So this is a great mode to use if you have an application where users are signing into the app with Cognito user pools and then using the JSON web tokens, the JWTs that they receive from the Cognito user pools to gain access to your API. So, like I said, great mode to use if you're authenticating users in an app, and also if you need to connect social identities using Cognito user pool, because that is another feature of Cognito user pool. And the other thing to remember is if you're going to build an app that also interacts with other AWS services, Cognito user pool is probably what you want to use, because you can exchange Cognito user pool's JWTs, your access tokens, for actual AWS credentials. So if you have an application that's also going to interact with something like an AWS service like S3, then Cognito user pool is probably what you want to use, because then you can use it to interact with an AWS service and to interact with AppSync using the JWT. And with the Cognito access mode, you can also implement granular access control with AppSync directives. So what you see here, for example, is a post field on my query type. And I'm using the AWS auth directive to specify which Cognito group should have access to this post. So in this specific case, I don't need to write any specific business logic. I can just use the directive on the field to specify who has access. And then when I write my resolvers, I can write additional business logic by using the identity of the Cognito user to figure out what type of access that user should have. So that's also pretty powerful. If we look at the OpenID Connect authorization mode, it's fairly similar to Cognito user pool, essentially because we are talking about using JWTs to grant access. So this works when you have something like an application that already has a user directory. And so maybe you have an external OIDC identity provider, right? You can set up AppSync to interact with that OIDC and to properly identify and authorize requests with the JWTs that have been provided. So this works well with apps where you need to authenticate users and you have an existing user directory. So the other thing to mention here, the one difference with Cognito user pools is Cognito user pools can actually be used to exchange to get AWS credentials. This is not something that you would be able to do with your OIDC identity provider. So it's a good mode to use, but just keep in mind that you wouldn't be able to interact directly with other AWS services. And just like with Cognito user pool, you can implement your granular access control using the claims that are available in the identity object that is made available to your resolvers in AppSync. So here you see that we're implementing something similar to what we had in the previous slide with Cognito, but here we're using the group information that's into claims for the specific identity. So same thing, we just pull up the groups. And we know that the allowed groups are bloggers and readers, and we just go through the list of groups to see if they belong to one of these groups. And if they do, you can then grant them access. If they do not belong to any of these groups, you can use the utility util.unauthorized to reject the request. The last mode that we'll look at is the AWS Identity and Access Management mode. So this is a mode that you use where you essentially use IAM to write permissions that grant access to AppSync. This is a great mode to use if you have backends running on AWS that are going to access your AppSync API when you're using AWS credentials, and even if you're using IoT systems that are using AWS credentials, you can then use your role that contains the policy to sign your request towards AWS AppSync, and AppSync will then validate the request and make sure that you're authorized to access the fields and the types that you want to access. And you can get pretty granular with the permissions here as well. As you can see in this IAM policy, you can specify which fields the user of the policy has access to. So this is pretty granular. So this is the mode that I would recommend using if you are accessing AppSync from an EC2 instance because they use instance profiles, or if you're using an AWS Lambda function to access the API. So here you can also specify the permission that the AWS Lambda function should have. Now, all of these modes work well by themselves, but AppSync actually allows you to use all of these modes at the same time on a single API. So this is pretty powerful. This means that you can do multi-authorization on your API and grant different type of access depending on who is accessing or what is accessing your API. So you could have a system, an AppSync system, where you have a Lambda function that's running and periodically updating your API. And that Lambda function uses an IAM role to gain access to AppSync. Now, on the client side, on the app user side, your users are interacting with the API using Cognito. And maybe you have an IoT system that then uses AWS permissions as well to gain access. Maybe you have users that are logging in through their OIDC IDP and then using those JWTs to gain access to your AppSync. So you can specify to additional providers as needed. You select the default mode and then you specify additional providers. And you can get pretty granular. You can specify which type of mode has access to different fields. So the multi-authorization setup is also pretty powerful. Let's take a look at protecting availability of your API. And here again, we're just talking about making sure that your API is available and provides the experience that your customers are expecting from it. So when you talk about AppSync, AppSync provides DDoS protection for every API that you configure. That means that it's built to withstand attacks and can scale to absorb those attacks. But it also integrates with AWS WAF to provide additional firewall type of functionality for your API. with AWS WAF, you can actually protect against exploits and that impact the security and the availability of your API. And the great thing about AWS WAF is that it's really easy to configure. AWS WAF is a web application firewall that runs on AWS. And it integrates with services like AWS AppSync, of course, AWS ALB, Amazon CloudFront, and API Gateway. But it's really easy to set up. Again, it's a managed service, so there's no infrastructure for you to manage. There's really low operational overhead. You simply use rules that you write yourself or use to manage rules that are provided by AWS. These are rules that are updated automatically to protect you against the most common threats like cross XSS detection and SQL injection detection as well. It's highly customizable. Like I said, you can use managed rules or specify your own rules. And you can also use third-party rules that you can find in the AWS Marketplace. So the WAF integration really opens up the door for a lot of additional security and protection of your API. And you can look at some of the use cases and what you can do with AWS WAF integration for AppSync. There's things like protecting your API against flooding, right? Turning off introspection in situations where you don't want it to be configured. You can support B2B APIs using API keys and making sure that your different partners or third-party partners do not overwhelm your API. And you can also limit access to Amazon VPC resources, which is one of the things that we'll look at. So when we talk about protecting against flooding, using WAF and using an access control list that you've configured in WAF, you can set up a rule that will actually throttle requests that come from individual IPs if they've exceeded a certain rate per 5-minute segment. So this is a good rule that you can set up to actually protect against flooding, bad actors that may try to overwhelm your API. You can turn off introspection. So this is going to make your schema not discoverable. So you may have a situation where for some reason you want to turn off the introspection. And just as a reminder, the introspection is a special query in GraphQL that allows you to discover your schema. For some reason, you may not want that to be your schema to be discoverable. So you can set up a rule that blocks any request that contains the special _ schema request. That way, introspection is turned off, and that only impacts introspection queries. The rest of the queries are not impacted. You can support B2B APIs using the API key. So you can set up, we looked at the throttling rules that you can set up, but you can also set them up in different ways given the different API keys that you may have set up on your API. So you can set up different API keys for different businesses that you are working with, and you can set different throttling rules for the different APIs. So that's also a way of configuring different levels of access and different throttling rules for different API keys. Another thing that you can do is greenlist access to your VPC. So you may have a situation where you have a VPC and you have an AppSync API. Now, you only want resources from your VPC, maybe your EC2 instances. You only want those EC2 instances or requests that are originating from inside your VPC to have access to your API. Well, what you can do is set up a WAF in front of AWS AppSync with a default rule that blocks all incoming traffic. And then you can set up one rule that allows traffic that comes from your NAT gateway elastic IP address. This way, you're blocking everything else, and you essentially have a private API that is only accessible from your VPC. So that covers protecting access. Let's take a look at protecting performance of your API. As I mentioned, the first thing you want to do when you talk about protecting the performance is making sure that you can actually monitor the performance, making sure you understand what's going on with the performance and with your API. Now, AppSync allows you to do that by providing CloudWatch metrics. So by default, you can monitor the latency of your API, and you can also monitor the number of requests that are coming into your API, the number of 400 errors and the number of 500 errors. AppSync also integrates with CloudWatch logs and allows you to send logs to CloudWatch. And you can use these logs to actually gain further insight into what is going on with your API. So with the CloudWatch logs, you can do two things. You can use Log Insight to do some ad hoc querying of your logs to figure out what is going on. For example, you could look at the tracing logs to understand the latency that your different fields and resolvers are experiencing. And if you find that insightful, you can then choose to create metric filters to create specific latency metrics for fields that you want to monitor closely. Now, once you've created those metrics, you can also set up alarms against those metrics to be notified if some of your field resolvers are taking more than a certain amount of time to resolve requests. And then based on those alarms, you may choose to take different action. Maybe you want to introduce something like a cache, or maybe there's some fine tuning that you need to do on your resolvers to improve the performance. Monitoring is good and important, but sometimes you also need to do some real-time tracing, and AppSync integrates with AWS Xray to do that. So AWS Xray provides end-to-end tracing in near real time, and it allows you to see how the different components that make up the call chain of your AppSync requests behave. So it's a great visual tool that you can use to identify performance bottlenecks, and you can see which component in the chain is actually contributing to most to latency. So in this example here, you have a request that is accessing both Lambda and DynamoDB, and you can try to figure out at which of these components most of the latency is being introduced, and then you can take steps to fine-tune. Now, to step to fine-tune, AppSync does provide an AppSync cache, and this is a cache that sits between your API and your backend resources. So if you run into a situation where you want to provide faster response time for some of your requests, you can introduce this cache. So it's fully managed. You can set it up to do full API caching, and at that point, all of the requests are cached, and then you will be able to provide that millisecond type of response to your request. Or you can set up per resolver caching. You may have some resolvers that you do not want cached, where the data is changing rapidly. But you may have some other resolvers where you know that the data does not change that much. Maybe it's a read-heavy system and you want to put a cache in front of one of your queries. So you can turn that on. And of course, you can turn on encryption as well to protect your data, both at rest and in transit. So we've looked at protecting your accessibility, protecting the availability, and protecting the performance. So these are different components that can really help you build APIs and get them ready for production. And when you really put it all together, you end up with an infrastructure that you can easily deploy on AWS. So AppSync integrating with these different services to build an infrastructure that's ready for deployment. So here we have AppSync integrating with Xray and Amazon CloudWatch, sending logs and then creating latency alarms. AppSync interacting with different backends like DynamoDB and AWS Lambda, and where needed, introducing an AppSync cache to improve the latency and to resolve time. And then we have AppSync integrating with AWS WAF, where you have WAF protecting your AppSync API from flood protection, rate limiting, and blocking introspection queries. So this is something that you can build with AppSync and with the different services that interact with AppSync, and it's something that you can deploy fairly easily with the AWS CDK. Now, the AWS CDK is a set of tools that allows you to build stacks and infrastructure using infrastructure as code that you can then deploy reliably on AWS in your account. And then you can deploy multiple times over time reliably as well. So then what I'm going to do now is jump into a demo and show you how you could actually build this infrastructure using the AWS CDK. So let's jump into the demo. I'm going to show an AppSync configuration that implements the capabilities we just went over. I'm in a CDK project using TypeScript. I have a schema that has a to-do type, so something that you would use for a to-do system, and you can interact with the to-do with your queries. You have get to-dos and list to-dos, and of course you can do mutations, something with a create to-do, and you've got subscriptions as well. The main data sources that we're going to use in this configuration is a DynamoDB data source. This is where we're going to be saving our to-dos. So you can see that I'm creating a table here, and then I'm creating DynamoDB data source from this table. And then I'm also using a Lambda function that I'm going to use to retrieve my to-dos with the list to-dos resolver. And then into Lambda function, I've introduced some variable latency so that the resolver might take more or less time to complete, and then we'll be able to look at that performance later on. So to begin with, let's take a look at how we implement multi-auth. For this API, I want both Cognito and user pool, Cognito user pool and API key to be set up as authorization modes. Okay, so to do this, I specified the API key as my default authorization mode. So this is what I'm doing here. So I've got this authorization config into API that I'm configuring. And then I set up an additional authorization mode for Cognito user pool. So again, I set the type and I set the value to user pool. And then I set the user pool config to this pool. And so I created a user pool here using the Cognito user pool constructor, and then I added a client to the pool as well. I also need to make sure that this is reflected in my schema as well. I need to add directive that specify which fields and types should be accessible to Cognito user pools. So let me go into my schema again and see what we have. So you can see that I've specified that both AWS Cognito user pools and AWS API key should be able to access the to-do. So both modes should be able to access this type. But you can see here that I've only listed the AWS Cognito user pools for get to-do. This means that only AWS Cognito user pool can access this to-do, and it won't be able to interact with any of the other mutations or queries because we haven't specified it. Okay, so let's take a look at the console. So I'm in the console for this API. I can sign in, and I'm already signed in with a Cognito user, and you can see here that I have two authorization mode. I've selected Cognito user pool, and I've signed in as a user. So now what I can try to do is try to get a to-do. And some of these to-dos have already been created, so I can simply come in here and try to retrieve a to-do, and let's see if this works. And you can see that I can do that. But if I try to do something else like listing a to-do, you can see that this is unauthorized, right? Because I don't have permission to do that. I didn't set it up in my schema. So that's pretty good. So now we've got the multi-authorization set up, and we were able to do that fairly easily. So next thing we want to do is looking at the availability piece. And so I want to configure AWS WAF integration for my API. So to do this, I created a new construct, and you can see that I'm using it down here. I've got a new WAF config, I call it WAF config, that essentially defines the WAF ACL into rules that I want. So I can jump into this construct, and the reason I implemented it as a construct is so that I can use it over and over again with the different APIs that I build. So in this construct, I'm defining a couple of rules. One of the things that I'm doing is I'm creating an IP set, and I'm going to use this as the IP set that is greenlisted to access my API, and we'll look at that in a second. But the first thing that I do is I create the WAF, okay? I give it a name, and I set the visibility so that we have metrics, so we will be able to see the number of requests allowed and the number of requests blocked. And then I define two rules. So the first rule is going to be a flood protection rule, and this is going to protect my API from flood protection and from bad actors from individual IPs. And I create a rate limit. So this rate limit is essentially stating that we should limit the number of requests from individual IPs to 2,000 requests per 5 minutes. And if the requests go above that, the WAF will start blocking the requests, so they will not even get to my API. The second rule that I set up is a rule that restricts access usage of the API key. So I want to limit the API key to specific IP addresses, and this is why I have the IP set that I greenlisted. So the way to do this is to set up an AND statement. So an AND statement is made up of two statements. The first statement that I have is a byte match statement that looks for an XAPI key header, and it checks the value of that header to see if it matches the value of the key from my API. That's the first thing. The next thing it looks at is to see if the IP is coming from if the request is coming from an IP that is not in my allowed IP set. And that if that is the case, if this statement matches and if this statement matches, then it blocks the request. So those are the rules. And then the last thing that I do, of course, is set up the association. So I want to associate the ACL with the ACL with my API. So let's test the IP restriction. If I wanted to do a list with my API key, I can do that. I'm going to use HTTPI to make essentially an HTTP request. So I'm doing HTTP post. I pass the URL of my IP address. I pass the API key. And then I pass the query. And then I'm going to pipe all of this through JQ. Let's see what happens. So this takes a bit of time, but I'm able to do it. And you can kind of see the results here. Now let's try to do the same thing with the API key from the console. So I go in here, I switch the mode to API key, and I'm going to do a list to-dos, items, ID. So what happened in the request that I made from the CLI, I've greenlisted the IP of this EC2 instance where I'm working, which is a different IP than the IP that I have here in the console. So these requests are coming from different IP addresses. So let me try to do the list to-dos from the console. And you see here, WAF forbidden exception. So the WAF has blocked this request. Okay, so that's pretty good. So now that we've done this, let's go back to the CLI and to the code editor and take a look at performance. So I have created a number of resolvers that I've associated with the fields for my API. And here are the fields. So I have a get to do, create to do, and list to dos working with the different data sources that we have. And then for each of these resolvers, we want to be able to track the performance, right? So we want to be able to construct metrics and metric filters for each of the fields so we can actually get a better understanding of what's going on. So to do this, I created another construct. And so for this construct, what I'm doing is I'm passing all of the fields for which we're creating resolvers. And then in the construct itself, I'm accessing the log group and creating a metric filter for each of the fields for which we are creating a resolver. And the way we do that is by using a log pattern. So in the log pattern, we look for a log of type tracing. This is a log that provides the amount of time a field took to resolve. And we search for the specific ARN, which consists of the parent type and the field name for the field. So here I have resolver ARN, and I just needed to match an ARN that has the type name, resolvers, and the field name. Okay, so now that we've had those set up, we have the metrics, and in addition to that, we can actually set up alarms on those metrics so that if the latency for any of these resolvers goes above 300 milliseconds, the alarm will get triggered, and then we can take action based off of that. Awesome. So there you have it. We've covered a couple of things, and we looked at the different type of capabilities that can allow you to take your AppSync API and get it ready for production. I hope you found this insightful. Here are a couple of additional resources that you can look into to learn more about AWS AppSync. Visit the website, the docs, or GitHub, or blogs, or look up more resources on the AppSync page on aws.amazon.com. Thank you very much for joining this session. Again, I hope you found this helpful and insightful. And thank you again.